Hello everyone, welcome to my channel Pharma Guide. Today we'll continue the topic manufacturing of tablets and we'll continue cover this topic bed granulation method today. I want to tell you that I am covering all these topics in very detail. You need not to do any literature survey. Just follow these videos, and if you like them, please share them, and if you're watching for the first time, please subscribe to my channel. Topics covered in this video will be steps involved in the wet granulation method. First is milling of the drugs and excipients, then weighing, mixing, wet massing of the powder mixture using the low shear mixer granulators, high shear mixer granulators, fluid bed granulators, dryers, spray dryers, extruders and spheronizers, spray congealing, then drying of the moist granules, sizing of the granulation, then lubrication of the granules, compression of these granules into tablets, then advantages and disadvantages of the this wet granulation method. At last we will discuss manufacturing of the tablet using the wet granulation method. I will show you one example explaining how the wet granulation method is used in the formation of the tablets. Okay, now wet granulation forms the granules by binding the powder together with an adhesive. Bridges are developed between the particles and tensile strength of the bond increases as the amount of the liquid added increase. Okay, amount of the liquid, this is the granulating fluid or the binder solution. So the binder is dissolved in the solvent to form the binder solution or the granulating fluid. It is then sprayed over the powder particles, and these powder particles, they stick to each other or bind to each other with the help of that adhesive or the binder. Okay, with the formation of the bridges. Bridges developed between the powder particles, and the tensile strength of the bridges or these bonds increases as the amount of the granulating liquid added is increased. Wet granulation involves the massing of a mixture of dry powder particles using granulating fluid. The fluid contains a solvent which can be removed by drying, and it must be non-toxic. Commonly used solvents are water, ethanol, isopropanol and methylene chloride, either alone or in combination. Steps involved in the wet granulation method we'll study in detail. First is the milling of the drugs and excipients. Why it is important? Milling of the API and excipients is important to obtain the homogeneity in the final granulation, so that there is there is proper mixing and no segregation of the drugs and excipients occur. The next step is weighing. Weighing should be done in clean area with the provision of airflow system. In the weighing area, all the ingredients must not be brought together at the same time to avoid the cross contamination. Next step is mixing. Commonly used blenders are double cone blender, V blender, ribbon blender, planetary mixer. You will find explanation of these blenders in my previous video. Any of the blender may be used to form the dry powder mixture. Okay, these blenders are used to mix the dry powder mass. Commonly used diluents are in the wet granulation method. They include lactose, microcrystalline cellulose, starch, powder sucrose, mannitol, fructose, sorbitol, calcium phosphate and calcium sulfate. Disintegrants that are used in the wet granulation method are cross carbamylose, sodium starch glycolate, sodium carboxymethyl cellulose, polyvinyl pyrrolidone, cross povidone, cation exchange resin, corn and potato starch, alginic acid and other materials that counteract the effect of the binders and the physical force of the compression using the forming of the tablets. So these disintegrants must counteract the effect of the binder, must break the particle-particle bond, and must also break the physical force of the compression used to form the tablet, so that the tablet may break into the coarse particles or the granules and then further help in dissolution of the granules. Now cross carbamylose 2% and sodium starch glycolate 5% are often used because of their high water uptake and rapid action. You will also find these tablet ingredients in detail in my previous videos. Step 4th is wet massing. Here the binder solution is mixed with the powder mixture to form an adhesive mass which can be granulated. Okay, binder solution is prepared. It is sprayed over the dry powder mixture to form an adhesive damp coherent mass which can be passed to the screen or which can be granulated. The amount of the binding agent used as well as quantity of the fluid required to form a damp and coherent mass is the part of operator's skill. Okay, this requires lots of skill, that how much amount of binding agent is to be added to form the damp mass. However, the resulting binder powder mixture should be compact when squeezed with the hands. Okay, so we can check manually that end point of the formation of the damp coherent mass is achieved or not. Nowadays, the torque meters are attached in the high shear mixer granulators, which will show you that the end point is achieved. There is a range of the torque between which you have to keep. When the reading achieves between that range, then that indicates that the end point of the formation of damp coherent mass is achieved. The use of the insufficient binder tends to poor adhesion, capping, and soft tablets. If insufficient binder is used, it will result in the softer granules, which will result in poor adhesion, capping, and formation of the soft tablets. If excessive binder solution is added, if excessive binder solution is added, it will result in the formation of harder granules, which will further result in formation of harder tablets with the slow disintegration properties. So binder solution must be added in the optimum quantity. Okay, wet massing can be performed by high shear mixer granulators, low shear mixer granulators, fluid bed granulators, dryers, spray dryers, extruders, and spheronizers, and spray congealing method. Okay, now low shear mixer granulators. Low shear mixers includes the barrel, cube, twin shell, double cone, slated double cone, ribbon, sigma blade, and planetary mixers. Although these low shear mixers are mostly replaced by the high shear mixer granulators. We'll discuss this planetary mixer. You can see top view of the planetary mixer as well as the complete equipment. Planetary mixer is used for the wet massing of the powders. Okay, the mixed powders are fed into the bowl. This is the bowl. The powder mixture is fed into the bowl of this planetary mixture, and then the granulating liquid is added, as the pedal of the mixer is responsible for wet mixing and kneading action required to form the granules. Powder is fed into this bowl, then the granulating liquid and kneading of this dry powder mixture takes place. The mixture is designed with the paddle having a planetary motion. Okay, you can see the top view of this planetary mixture. This is the mixture blade. Here the paddle is attached. This is the stationary gear, and this is the planetary gear. This is the direction of drive. So this planetary gear will result in the rotation of the paddle like this. So this is designed to have a planetary motion. Okay, design is such that there is a narrow or limited space between the wall and the blade of the mixture. There will be very limited space between this wall and blade of the mixture. This space is very less, so that to avoid the void space. Now high shear mixer granulators. High shear mixers are stationary cell mixers with a large mixer scraper blade. This is the this is 3-bladed impeller. This is the large mixer is scraper blade. Okay, which mixes the ingredients, eliminates the dead points, and presents the ingredients with a high speed chopper blade. This is the chopper blade, which initially mixes the ingredients also and also breaks the lumps. Advantages of the high shear mixer granulators are: this is simple method, robust technology, production of the high density granules, rapid and efficient mixing, low liquid is required or low granulating fluid is required, and it is also equipped for drying. Okay, the machine has a stainless steel mixing bowl. This is the mixing bowl containing a main impeller, this 3-bladed main impeller, which revolves in the horizontal plane, and an auxiliary chopper or the breaker blade. This is the auxiliary chopper which revolves either in the vertical or in the horizontal plane, and it functions as a lump or agglomerate breaker. Lumps and agglomerates are formed during the kneading action of this wet powder mass. So these are break with the help of the chopper blade. Okay, how the formation of granules is done in the high shear mixer granulators. The active ingredients, diluents, and part of disintegrants are mixed or blended well. Then the solution of the binding agent are added or sprayed to the mixture, this dry powder mixture, with the stirring. The powder mass is wetted with the binding solution until the mass has consistency of the damp snow or brown sugar. This will show the end point of the formation of the damp mass. If the damp mass attains the consistency of damp snow or the brown sugar, then we will stop the adding of binder solution. If the granulation is over-wetted or if granulating fluid is added in more quantity, then the granules will be hard, requiring considerable pressure to form the tablets, and it will result in the molted appearance also. If the powder mixture is not wetted sufficiently, or if the granulating fluid added is not in the sufficient quantity, then the resulting granules will be too soft, breaking down during the lubrication and causing difficulty during the compression also. In the modern high shear mixers, the end point of the wet granulation is no more dependent on the experience of the operator or with the hand feeling. Okay, this is measured accurately by a torque built in the torque meter. There is a torque meter attached in the high shear mixer granulators, and there will be a range which will be validated during the validation process. So when the torque is within that range, that will show you that the endpoint is achieved. This damped snow and brown sugar, this is only to explain you the consistency, that this is the consistencies to be achieved. But in the modern or high shear mixer granulators, a torque meter is there to show the formation is completed of the damped mass. This consistency and reproducibility from the batch to batch are assured. With the help of this, the consistency and reproducibility from the batch to batch is assured. The wet granulation mass is then forced through the 6 or 8 mesh screen. Small batches can be passed through by the hand using a manual screen. For the large quantity, one of the several commuting mills are suitable for the wet screening. Okay, now fluid bed, granulators and dryers. The powder particles, these are fluidized in the stream of the air. In addition, granulation fluid is sprayed from a nozzle to the bed of the powder. You can see this is the expansion chamber. This unit is divided in this and this part. This unit is taken out, powder is fed into it, then it is attached. Then the stream of hot air is, this hot air is blown or it is sucked in this area. And this hot air will cause the fluidization of the powder particles in the expansion chamber. This is the spray nozzle. So granulating fluid maintained at some temperature, this will be sprayed onto the powder particles from here. This is the example of our bottom spray Wurster coating. This is the Wurster coating method. The granulating fluid is heated, pumped from a reservoir through a spray nozzle positioned over the bed of the particles. The filtered air is blown or sucked through the bed of the unmixed powder to fluidize the particles and mix the particles. Fluidization is a very efficient mixing process also. The fluid causes the powder particles to adhere when the droplets and the powder colloids. So when the droplets of the granulating fluid and the powder, they colloid to each other, these droplets causes the powder particles to adhere to each other to form the granules. Powder particles will adhere to each other when the granulating fluid colloids with them. This will move our dry and the particle will come down. So this process will go like this and the formation of granule will take place. The rate of the addition of binder, temperature in the bed of the particles, temperature of the air, volume and moisture of the air, it plays a very important role in quality and performance of the final product. What factors are important? Binder, rate of addition of the binder, temperature in the bed of the particles, temperature of the air, volume and moisture of the air. These are important in formation of the quality and performance of the final product. Okay, now depending on the position and location of the spray nozzle, the fluid bed process, it can be characterized in the top spray, bottom spray and tangential spray. If Wurster tube is attached to this bottom spray, then this is called the Wurster coating, and at last there are the adjustable cylinders in this last type. In top spray, the nozzle is located at the top of the expansion chamber. In the bottom spray, the fluid bed or the Wurster fluid bed method, the solution or suspension, this is sprayed on the fluidized bed from the bottom spray nozzle. Okay. The third is the tangential. Here the nozzle is introduced at the side of the expansion chamber. Okay, what happens here? First, the spinning of this disc, it generates the centrifugal force, and a lifting force is generated by the hot air which passes through these adjustable disc gaps. Okay, so the centrifugal force and this force generated through the hot air introduction from this adjustable gap, it will cause the lifting of the particles, and then gravitational force will cause these particles to fall down. So particles will revolve like this. There are some important points. Top spray coating. This processing option is very elementary one. A perfect film is generally not formed as compared to the bottom or the side spray. Bottom spray, The bottom spray coating, called the Worcester fluid bed process, is for the precision application of the high quality reproducible film. This is for the precision of the film onto the particulate matters like powder, crystals and or granules. It can be used to encapsulate the solid materials with the diameter ranging from 20 micrometer to more than 1 centimeter with a high quality reproducible films and highly organized particle flow. So particles of 20 micrometer to more than 1 centimeter can be encapsulated. For the film coating, the bottom spray process produces a smoother and more uniform coating and higher coating efficiency as compared with the top spray and the tangential spray. So bottom spray is better than both. Tangential spray, this processing is similar to the bottom spray coating, only that the production motion is produced by a motor driven rotor disc. The uniform and desired resistance time is achieved by the motor revolution speed. The rolling motion of the particles provide an even higher separation force, preventing the agglomeration of the powder particles. However, this high movement makes it difficult to coat very small particles. It is not good for the very small particles and generally destructive for the large and non-spherical products also. This is a general difference between side tangential spray and top spray. In side and tangential spray, denser and less fragile granules with the large particle size are formed. Denser, less fragile granules of large particle size. In top spray, granules formed are less dense, more fragile and of the smaller particle size. Advantages of the fluid bed granulators: rapid wet mixing, agglomeration and drying is carried out in the single unit. Fluidized bed dryers are 15 times faster than the conventional method of tray drying. Better control of the drying temperature, decreased handling cost and opportunity to blend the lubricants and other materials into the dry granulation directly in the fluidized bed. This blending of the other materials can also take place during the granulation. In addition to the granulation, this technique has been proposed for the coating of the solid particles as a means of improving the flow properties of the small particles. Disadvantages: optimization of the process parameters needs extensive work. Lot of validation or optimization is to be done not only during the initial formulation work but also during the scale up from development to production. There is tendency of demixing or segregation of the powder particles if there are disparities in the particle size or if there is large particle size distribution, and also differences in the density of the material being processed. It may lead to demixing. Particles under granulation has tendency to stick to the equipment filters. This reduces the effective surface area of the filter, and this also causes the product loss and increase in the cleanup difficulties. There are the equipment filter which are attached at the top of the FPD to so that the powder particles may not escape from the equipment with the flow of the that hot air. So the filters are attached at the top. Now the powder particles may attach to these filters. This will reduce the effective surface area of the filter also. This will cause the product loss also and increase in the cleanup difficulties. Okay, now spray dryers. A number of tableting additives suitable for the direct compression have been prepared by the drying process known as spray drying. Lots of directly compressible material are converted into this directly compressible form by the spray drying method. The method consists of bringing together a highly dispersed liquid and a sufficient volume of hot air to produce evaporation and drying of the liquid droplets. The substance which is to be converted into the spray dried form, it is first dissolved in a liquid to form a highly dispersed liquid. It may form a slurry, a solution, an emulsion or gel or paste, anything which is pumpable through an atomizer. Okay, so we'll dissolve the substance to form a slurry, a solution, emulsion, gel or paste, provided it is pumpable and capable of being atomized. When it is atomized, hot air will be introduced which will produce the evaporation and drying of these droplets to form the spray dried product. The spray dried particles are homogeneous, approximately spherical in shape, nearly uniform in size and frequently or somewhat hollow. Among the spray dried materials available for the direct compression formulas are lactose, mannitol and fluor. Among the heat sensitive pharmaceuticals, successfully Spray dried are amino acids, antibiotics such as aureomycin, brachytrazine, penicillin, streptomycin, ascorbic acid, cascara extracts, liver extracts, pepsin and other similar enzymes, protein hydrolysates and the thymine. These all are heat sensitive pharmaceuticals which are successfully converted into spray dried product. The oil soluble vitamins A and D can be coated with a variety of materials such as acacia gum to prevent their deterioration. Flavoring oils and synthetic flavors are coated to give the dry flavors. Extruders and spheronizers. Spheronization or a form of pelletization refers to the formation of spherical particles from the wet granulation. Spheronization mainly deals with the formation of the spherical particles from the wet granulation. It is used primarily to produce the multiparticulates for the controlled drug release applications. A wet granulation containing a drug substance, diluent and a binder. Drug substance, diluent and binder, these are passed through a extruding machine to form a rod shaped cylindrical segments. Okay. So this damp mass is passed through the extruding machine to form the rod shaped cylindrical segments ranging from the diameter 0.5 to 12 millimeter. After this extrusion, the segments are placed in a maromerizer where they are shaped into the spheres by the centrifugal and the frictional force on a rotating plate. There is a rotating plate in a maromerizer where these rod shaped cylindrical segments are placed. It will rotate, this plate will rotate, producing a centrifugal and a frictional force, and these force will result in formation of the sphere from the rod shaped cylindrical segments. Advantages of the process includes for production of the granules, regular in shape, size, surface characteristics, low friability resulting in fewer fines and less dust, and ability to regulate the size of the spheres within a narrow particle size range. Main steps in the spheronization process are: first, dry mixing of the ingredients uses normal powder mixing equipments. Then wet massing. This stage also employs the normal equipment and processing as used in the wet granulation. Okay, third step is extrusion. It produces the rod shaped particles of the uniform diameter with the wet mass. The wet mass is forced through the dies and shaped into the small cylindrical particles with the uniform diameter. Extruders can be divided into three classes based on their feed mechanisms. First is the screw feed extruders. You can see this axial and radial extruders. Axial or end plate, dome and radial extruders are there. Then the gravity feed extruders, cylindrical roll, gear, roll or radial. Third is the piston feed extruders. Okay. Now the primary extrusion process variables are feed rate of the wet mass, diameter of the die, diameter of this die, length of the die, water content of the wet mass. Okay, these are the important variables. Feed rate of the wet mass, diameter of the die, length of the die and water content of the wet. Okay, now spheronization. Function of this fourth step in the process, that is spheronization, is to round off these rod shaped segments, cylindrical segments produced by the extraction into the spherical particles. Okay, these segments, this cylinder is first converted into cylinders with the round edges, then the dumbbell, then ellipsoid is formed, and then at last a sphere is formed. Okay, this represents the mechanism of spheronization. This is the maromerizer or a spheronizer. Okay, this is carried out in a relatively small piece of apparatus, drying. A drying stage is required in order to achieve the desired moisture content. This is the final step in the process. Then screening. Screening may necessary to achieve the desired narrow size distribution. Normal sieves are used. Although both immediate release and controlled release pellets can be formed, the most common application of this process is to produce the spherical pellets for the controlled drug release. For the controlled drug. Okay, now spray congealing method, also referred to as spray chilling. Spray congealing is a technique similar to the spray drying. It consists of the melting solids and reducing them into the beads or the powder by spraying this molten feed into the stream of air or the other gases. Okay, the solids are melted, then these are sprayed in the stream of the cool or air at the room temperature. Okay, no requirement of the heat is there. Okay, the same basic equipment is used with the spray drying, although no source of heat is required. Either the ambient or the cooled air is used, depending on the freezing point of the product. For example, monoglycerides and similar materials are spray congealed with the air at 50°F. A closed loop system with refrigeration cools and also recycles the air. Using this process, drugs can be dissolved or suspended in the molten waxes and they can be spray congealed. The resultant material can be adopted for the prolonged drug release form of the drug. Now, after the wet massing, step 5 is drying of the moist granules. Drying is usually carried out at 60°C. Depending on the thermolevel nature of the drug, the temperature can be optimized. The drying is required in all wet granulation procedures to remove the solvent, but is not dried absolutely. Some of the moisture is maintained in the granules because it may, if completely moisture is removed, then it may pose some problems later. Hence, certain amount of moisture, generally 1 to 4%, is left within the granules, and this is called the residual moisture. Okay, now methods of drying. First is the tray dryers. It takes 24 hours of drying. This is an older technology similar to the baker's oven with a lot of manual manipulations. Liquid can only be lost from the upper surface of the granules. Packed in the tray, the lower surface of the granules may not be dried uniformly. This is known as case hardening. Okay, case hardening may sometime occur in the tray dried product, in which the outer surface of the lumps of the powder, wet powder, will be dried quickly and become hard. It will form a crust. So, on the surface, crust will be formed, and inside or in the inner part it will remain wet. This is the case hardening. Truck dryers, the whole cabinet can be taken out of the dryer. Fluid bed dryers require 30 minutes of drying. Fine mesh at the base and cloth filter at the top. It prevents the granule from escaping. Warm and dehumidified air is passed up through the base at such a force that it fluidizes the granules. The liquid can be lost from a much greater surface area. So the drying times, it is shortened. Okay, the movement of the granules may lead to the attrition. Microwave or the vacuum dryer, it requires tens of minutes only. Okay, maximum batch size is limited to allow the penetration of the radiation, gives rapid drying with relatively low temperature. Okay, now sizing of the granulation by dry granulation. The dried granules are passed through a screen of a smaller size than that used to prepare the moist granules. The screen used in the during the preparation of the moist granules is of larger size than compared to the screen that is used for the dry screening of the granules. The size of the final granule depends on the size of the punches and hence the size of the tablet. According to the size of the tablet, the punches are decided, and according to that only the size of the granules is decided, that from what mesh screen the granules will be passed. In this table you can see, according to the diameter of the tablets, these are the mesh size of the screen from which the granules must be passed. Okay, the lubrication of the granules. After dry granulation, the lubricant is added as a fine powder. Okay, it is usually screened onto the granulation. These lubricants, these are screened over the granulation, over the granules through the the lubricant is first passed through the 60 or 100 mesh nylon cloth to eliminate the small lumps as well as increasing the covering capacity of the lubricants. The lubricant is blended very gently using a tumbling action to maintain the uniform size of the granules. If overblending is there, then the granule may also break, producing the fines. Too much fine powder is not desirable because the fine powder may not fade into the dye uniformly, causing the weight variation and the variation in the density also. Since the very nature of the lubricant produce hydrophobic surface on the particles, hence overblending prevents the intergranule bonding that takes place during the compression. Due to the hydrophobic nature of the lubricant, this lubricant form the covering or a film over the particles. If complete covering occurs, then this complete hydrophobic film formed over the particles will prevent the intergranule bonding, which takes place during the compression. Hence, overblending of the lubricant must not take place. Okay, now compression of the granules into tablets. Here the mixed granules are compressed into the single punch or the multi-station tablet press fitted with the appropriate punches and dies. Compressed tablets may be coated. If there is need to mask the taste of the unpleasant drugs, increase in the aesthetic appeal of the uncoated tablets. If modify or control release of the therapeutic agents from the tablets is required. Okay, this is achieved by enclosing or covering the core of the tablet or the granule with a coating soil. Now, advantages of wet granulation. The wet granulation modifies the properties of the formulation ingredients. Granules formed, these are more relatively spherical than the powders, and this has a better flow properties. The improved compressibility of the granules allow the use of low pressure during the compression, thus reduces the machine wear and thus improves the life of the machine. The process makes use of conventional excipients and therefore is not dependent on the inclusion of the special grades of the excipients. It ensures the better content uniformity, especially for the low dose drugs. The process may improve the dissolution rate of the poorly soluble drugs by imparting hydrophilic properties to the surface of the granules. The wet granulation prevents the segregation of the components of the homogeneous powder mixture during the processing, transferring, handling, storage, leading to reduce the batch variability. Okay. Now, the tablet manufactured by the wet granulation are amenable to post-processing unit operations such as tablet coating. Wet granulation reduces the level of dust present during the manufacturing process, thereby reducing the incidences of the cross-contamination and risk to the workers. The wet granulation reduces the amount of the air entrapment, thereby increasing the powder compressibility. What are the disadvantages? Limitations. The wet granulation often requires several processing steps. The cost of the wet granulation is higher because of the time, labor, energy, equipment and space required for the process. The process is not suitable for the thermolabile and moisture sensitive materials. Migration of the soluble dye may occur during the drying process. Incompatibilities between the formulation ingredients will be aggravated or increased by the granulating solvent, which tend to bring these ingredients in close contact. Okay, there is possibility of material loss during the processing due to transfer of the material from one unit operation to the other. The dissolution rate of the tablet manufactured by the wet granulation may decrease with aging. It may happen sometime. Now we'll discuss one example, the formation of the ferrous sulfate tablets using the wet granulation method. The ferrous sulfate 300 mg is the active ingredient, cornstarch 60 mg is the diluent, 20% sugar solution is the binder, explotab 45 mg is disintegrant, talc 30 mg is glidant and antiadherent, magnesium stearate 4 mg is the lubricant. So ferrous sulfate and cornstarch, active ingredient and diluent, these are mixed, moistened with the binder solution or the sugar solution 20%. Then this wet mass is passed through the 12 mesh sieve. Okay, now wet granules are dried on a tray dryer at 60 to 65 degrees Celsius overnight. Then these dried granules, these are screened through the 18 mesh screen. 18 mesh screen is finer than the 12 mesh screen. These dry granules are then mixed with the explotab, disintegrant, talc, antiadherent, glidant and then the lubricant. So all these things are mixed or blended well, and then compression of this material takes place in the tablet press to form the ferrous sulfate tablets. Okay, thank you for your time and attention, guys. If you really like content of my videos, please like them, share them. It takes a lots of time for me to make these videos. If you like, please share. Thank you.